Okay, I'm not sure what's the deal here. I don't know if you guys saw the last 3 minutes. Cause like my recording software said I went live, and YouTube, if you look at the rewind, the preview I get to see has like a 3 minute rewind buffer, but it says I've only been live for 20 seconds. So I guess all that stuff I said for the last 3 minutes nobody got to see. Amazing, or hear. I was just sort of mulling on Advent of Code and how failing to finish day 8 part 2 sort of left me a little bit, my morale a little bit low. I've gotten some comments from people in Red, on the subreddit, some more reasonable ways to solve it, but I don't really want to go back and apply them. And day 9 still looks like it's going to take a while, so I don't know about going back to that right now either. But I do still like doing Advent of Code, and days 11 and 12 look manageable, having looked at the problems ahead of time. So I wanted to catch up before we get to tonight's problem, which maybe I'll do tonight, maybe not, who knows. So I'll do at least 11, maybe 12, maybe I'll do 12 later, I don't know. Am I crazy? YouTube keeps scaring me. I mentioned this in a recent video. It's like, oh, by the way, your audio bitrate is low. Like, it's 0. You might want more audio. And I'm like, oh my god, have I been muted this whole time? No, I haven't. YouTube's just like, oh, you stopped talking for a second, so we thought we would scare the shit out of you. Thanks, YouTube. All right, so let's just move on to day 11, shall we? Day 11, Dumbo Octopus. You enter a large cavern full of rare... I'm so distracted by YouTube. Like, I can just pause the preview. Okay, it's so distracting that, like, it's moving with my mouse, but, like, at a delay. I hate it. Okay. I think now I'm not having to look at that. Okay, great. Why does it say... You're not gonna believe this, guys. YouTube is just so bad. Sorry. But it says we're at 5 minutes and 14 seconds, or now a bit later, I'm sure. Out of an hour and 5 minutes, 14 seconds. It's sure I'm going to keep recording for exactly 1 more hour. I don't know why. Anyway, we don't care about that. Where was I? Day 11. They seem to not like Christmas lights, so you turn them off. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Each octopus has an energy level, and your submarine can measure them. That's your input. The energy level of each octopus is a value between 0 and 9. Top left has a value of 5, and so on. During a single step, first, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this also causes an octopus to have an energy level greater than 9, it also flashes during the same step. This process continues as long as new octopuses keep having their energy level increase beyond 9, but an octopus can only flash at most once per step. Finally, any octopus that flashed during the step has its energy level set to 0, as it used all of its energy to flash. Yes, so... adjacent flashes can cause an octopus to flash, even if it starts with very little energy. They have this example where it's a 1 surrounded by a bunch of 9s. The 9s all blow up, and that gives the 1 8 more energy, so in addition to the 1 that it gained, so it goes up to 2, then it gains 8 more from adjacent flashes, and then it flashes as well. Yes. Okay. So, simulate 100 steps. What, I wonder, might part 2 be? Is it just going to be simulate more steps? And, like, they're testing that you've done it efficiently? That doesn't seem likely, because this doesn't seem hard to do reasonably efficiently. And to do it, like, more efficiently, I don't see any solution other than just, like, simulating it. And the various ways of doing it don't seem particularly more efficient. So I expect part 2 will be something else. What might they change where this input would still be meaningful? You know, they might change how much energy octopuses gain per turn, or how much they can hold, or something. I'm just thinking, because if I build everything exactly for part 1, it might be a bit difficult to pass parameters into the part 2 thing, because as you recall, I do like to have my solution, once it's fully checked in, solve both parts. I don't like to solve one and then like cannibalize that solution to solve part 2. So one thing we could do, I think would be an interesting exercise, or at least instructive. I don't think it's that much of an exercise for me. Would be to start with data. I mean, I guess we could use new type even. Well, whatever. We'll just say data. Data parameters. Parameters of unit. Oops, unit. So right now, our parameter object is empty, and I'll try to plumb that through the solution. Part 1 won't look at it because I don't know what's important to parameterize. But part 2, if there's some detail we need to change in how stuff is processed, I want to have access to the parameters object that I'm going to plumb through all of the interesting functions. So what we're going to want is import control monad state. Is that legal or is it trans state? Okay, so I can have control monad state. Great. I don't think I'll need any weird transformers. So we'll just leave that there. And I guess what I'll do is run reader. What is the type of run reader again? Like, oh, I don't need state reader. So what is the type of run reader? You're not very helpful. God. I'm just trying to think what order it takes this thing. Well, run reader must give you back function, which means it must take the okay. Okay, so this will be a reader parameters input, and this will be a reader parameters input as well. No, this doesn't make sense. Function from input. Whatever, we'll just write these out. Pure empty, is that right? Parameters is spelled wrong. Didn't match parameters with reader t input. Oh. So, type of run reader takes the R and then the A. So is this not right? What's wrong? Get a full actual error message here. Parameters with reader t. All right. The problem is it wants an input to return the reader t. Ugh. Okay, maybe it's more of an exercise than I thought. I need to give it the input first. I mean, I guess I could just do something weird, couldn't I? I could say this is a reader. Yeah. I could say this is a reader parameters of input to unit. Like that. And the types are wrong. Good mesh parameters with reader T. I hate you so much. On line 20. What have I done? So part 1 and part 2 are now they're readers, and you give them a parameters object, and they give you back a function. Let me make sure that GHCI agrees with the Emacs integration here, and that it's only actually mad about main definition. So what's wrong with this? This is what I get for generalizing early. I might not even need all this stupid stuff. So you're complaining. Oh, do I have to flip the order of? I always get this. Okay, remind what is the parameter order of run reader again? Takes a reader RA. Okay. I have to put part 1 here. And part 2 here. Okay, great. So this is such a bizarre way to do it. I don't think it's even right, is it? Because this sucks. Because now I don't have the this is just what I get for writing a weird main. Okay, undo all that shit. Give me back the reasonable types for part 1. We're just gonna have to write a different different main. So let's main equals do. We're just writing this thing from scratch. Input is read file input.txt, and we'll pair it as well. And then we're going to print I don't need to do any more IO actions, so I can print run reader. No. Part 1 is a function of input. So what I'm meant to do is say part 1 of input and then give it the empty parameters. Is that right? That looks good. I guess print is weird because is it gonna? Well, let's just run it and see what happens. Stack run. Error? What, do I have indentation weird? What? Oh, I didn't close my parents. Do they wind up on different lines? Oh, I don't have my input file. Okay, we get 2 units. Fine. Great. So we can finally write part 1 now with this stupid reader that we're going to have to stick onto everything. And of course, it's not going to return a unit, it'll return an int, but whatever. So how do we actually implement this? I think that it's reasonable. Like, there's a number of ways you could like represent the input. I think an array is actually pretty reasonable. I always have to look up how to use arrays. Import data array. I don't know, I always kind of just want to use a map though. But an array has bounds, which is kind of nice. So if I do this, do I get array? Oh, yes, add array to day11.cabal. That's very sweet of you, thanks. Just give me array, I don't care what version. Add dependency array to executable section? I guess? I don't really know what that means. Yes, save the cabal file? Oh wow, yeah, add that to my GHCI session too. That was pretty cool. Did it work? Looks like it worked. Alright. Yes, restart GHCI, although I thought that happened already. Oh, that's a different okay. This is the process not controlled by HLS. Alright. So that actually kind of worked. Let me just grab the docs for data.array. Data.array. It has an index parameter and an element parameter. And I'll show you guys. So we have like, you can make an array that takes, okay. If I want a list array, I know that's a thing you can do. List array, fine. Actually, array is probably better, so I can keep the coordinates. Well, I don't know. I can just specify the bounds and then read all the ints, right? And then put them in, and it'll handle the order for me. That's kind of nice. How do I, like, these are immutable arrays, which is fine, I think. As for each step, I can just do a loop over the whole array and like produce a new fine. Okay, and it has a map, that's kind of nice. I assume it's more efficient than just mapping and then saying build a new array. Although I don't really want a map, do I? I want to be able to look at the neighbors of an element somehow. And I like, is there some way that I can, I guess it's a soaks, right? I have cum AE, that's basically a fold. I don't know what, I don't need this, I think. Just update something. Adjust actually modifies an array, which we're not going to be doing. A cum array. I don't need this. I think I'm just going to have to use a soaks basically to like take the array and turn it into a list of, I don't know, it kind of sucks, right? But when Like, we're gonna need some step somehow that, like, iterates over the array. I want to, like, filter the array for positions that are where the value is 9, basically. We won't actually use 9. We'll use a different thing that's like this thing's about to explode, but sure. And then once I've done that, I guess I want to adjust each of those indices neighbors. So is there some way that I can look at... I mean, I guess it's just a soak. So I get out a list of key value pairs, and for each one, if its value meets some criteria that I want, I'll do something with the index. Okay. All right. Well, it's still not like gonna look amazing, but let's at least do some simple stuff here. Let's define some types we're gonna want. So first thing is data octopus. We're gonna want some of these, right? Octopus of A. I don't think I'm gonna need to parameterize this. I think I want it to be just a concrete type. So an octopus is either exhausted because it's already gone off this turn, or energized because it's going off soon. So it's going off this turn but hasn't yet. Or it's latent with an int. Right, that's the amount of energy it has pending. And I guess what we can do is we can write, for example, a function that will be useful is add energy is a function from, I don't know the right order. Let's say, actually I want a new type energy instead of using ints here, just so I can't get them confused with other ints, like indices. Probably not. I don't think I'm going to get that mixed up. All right, let's take an int and an octopus, or add energy of O is case O of. If it's exhausted, then it stays exhausted. If it's energized, actually, we can say if it's latent. Oh, hang on, I have to put a E here. A? Okay. Latent B, where A plus B is greater than or equal to 10, then we get an energized octopus. Otherwise, it's a still latent octopus with energy of A plus B, and in any other case, we just get back the original octopus. Right? Adding energy to an exhausted or energized octopus does nothing. Adding energy to a latent octopus either adds energy to it or causes it to become energized. So this seems like a useful function that we will use at some point. I'm also like kind of annoyed because I think I'm going to need a map as well. Or am I? What if I used another array? Because, like, okay, I mentioned we're going to be iterating over the array and finding the... Well, we could just do... We don't have to actually coordinate these at all, do we? It would be kind of cute if we said, okay, this octopus is next to 3 that are blowing up, so we'll add 3 to his energy. But I could just, like, add 1 to his energy 3 times, and that would be fine. And in that way, I can just deal with a list of exploding octopuses. I know it's flashing, but like whatever. I like exploding. Well, this should probably take a reader to take the parameters in case we're somehow changing in part 2 how octopuses transition into transition states. But we can just ignore the parameters for now because we don't know how to use them. If we were calling any of their functions, it would be a good idea to pass along the parameters, but here we're not, so we can just do this. Cool. So I think we want, like, we want a function called, like, well, eventually we're going to want a function called step, but I feel like that's too high a level to work at. We're going to need to do several things inside of step, and I might like to write those. I guess we should define our input somehow. A type that is an array of int, basically. But type cave, I don't know, is an array int to octopus. And I guess we can start by writing step, and we'll just leave it kind of half filled in. Step is a function from cave to reader parameters cave. Well, is it though? Because we're not just modifying the cave. We have to decide whether anything changed. No. The step function. Right. So the problem defines an actual concept called step. Where's my browser? Hello, browser? Here it is. Often we just use step as like a useful name for a function that ticks forward by one time unit. Here, though, since the problem actually defines what a step is, I think we should use that nomenclature for our thing. And so step steps the cave forward by one time unit. We may have to do many updates within a step. But our step function is a function from cave to cave. And step equals, nothing. We also, though, need a function that, that, like, processes a cave during a step. We kind of have, like, octopuses who might be energized and need to become exhausted, right? What do we call such a function? We could tickle the octopuses, call it tickle. That doesn't seem quite right. Not really harvesting. It's like we're processing the side effects. We're processing the consequences. I don't know. Let's call it something completely meaningless like process, and then it can never be wrong, right? Process is a function from cave to... I'm sure there's a good name somewhere where you take something to its logical conclusion, right? You complete... Oh, complete's not bad. Complete. So it'll be a function that from a cave to, again, a reader parameters cave. But it'll call itself recursively only if it didn't do anything in one kind of tick, right? And so step actually can be fairly easy, I think. Step. I don't even know how to use readers, by the way. How to read anything clever and point free, so I'm not going to. Step cave is do a map. No. Let C prime equal a map add energy 1 to over C. Is that, did I get the type for a map right? A map, of course I did. We're going to add 1 energy to all the existing octopuses, which we assume will, by the way, all be oh no, we have to do more than that because we have to track how many flashed as a result of that step. Right. Okay, so let's say it doesn't return a cave, but rather a cave and an int, which is the number of octopuses who flashed. And then completed comes from complete C prime. I think this is fine. And we're going to have... It would be kind of nice if we could promise that a step function always produces only latent octopuses, right? And that complete could return octopuses which might be exhausted but never energized. Energized octopuses are kind of a concept that only makes sense inside of the complete function. I don't really know what I should do to make that a reality, so I'm just gonna like keep that promise in my head, hopefully. So we're going to say that we're going to let num flashes equal length of filter exhausted, I guess, of the elms of completed? Does that seem right? Go over all the exhausted. Find the octopuses who are exhausted because they flashed this step. Is elm the right name here? Yes. Okay, and then C prime prime, oops, will be a map revitalize over completed, and then we're just going to return pure of C prime prime num flashes. And I think we only need revitalize as part of step. I'm a little worried that one of these might need the parameters, but I guess if it does, we can adjust this function pretty easily, pass them in. So okay, where revitalize of exhausted is energized, revitalize of anything else is just that thing. And we still need exhausted, which I will put up here because I expect we will need it in complete as well. It's pretty simple. I don't know, maybe we won't need it in the other one, but exhausted is a function from octopus to pool, exhausted equal. I mean, I don't know. I guess I could just derive show. Not show. Eek. And then I wouldn't need this. I could just say filter equal right? Type signature for complete. Yes, I haven't written it yet. But suppose that I had. Is everything else okay? Yes, it just noted that there's a hole here, which is fine. I think that's the only. I still don't trust. Yes. Oh, you need a new GHCI session because of array. So there's a cave there. Oh, but there are more problems with AMAP. I thought AMAP was in data.array. Am I wrong? It is. Oh, I'm looking at the wrong array package. Damn it. Data.array. I mean, I can just use fmap, obviously. Okay, here's the real array type I should be looking at. The array derived arrays, ix map. Okay, I think it's just gonna use fmap basically, right? Mental updates, accessing list array. Okay, this just has a little bit less than the ghc.array. That's fine. Instead of amap, I should just be using fmap to begin with. So how about now? What? Completed? You're confused because you thought there would be an octopus and something actually wants a reader of octopus. Okay, and where is that? C, complete C. Okay. Why is there an octopus anywhere? Shouldn't there be a cave or something? Oh. Right. Fmap. What line is this stupid error on? Line. The argument of complete. Here. You're saying that C prime has type array int reader. Thought it would be a cave. I think it should be a cave. Why is it an array of readers? That doesn't make any sense. Okay, we must have gotten the type wrong somewhere. The complete of cave returns a reader, parameters, and cave. So this should be a cave now, right? I have a cave. I've fmapped over it. What? Okay, so suppose that I said, can I put a type parameter here? Is that allowed? I want that to be a cave. You can't do that. So I want this then to be a reader parameters cave. That's what it is, right? Yes, it's still the same error. That's the type it inferred. But it's saying that an array of int to readers? What did I do? Oh, it's because I made this add energy function. Take. It has access to the parameters, and so I can't just map it over an array because it needs. Okay. So I shouldn't be Okay, so the problem is that this C prime already has the wrong type because I mapped. Okay. So I think this can just be traverse. No, of course not. Oh, this is the worst. Monad stacks are so hard, and my stack is of size 1. All right, how do I do? What is going on? Are arrays traversable? Do I need them to be traversable? I'm not even sure. I guess I can ask that question. I think it should be, right? Traverse. Yeah, arrays are traversable. So add energy 1 returns a function from octopus to reader of parameters octopus. Oh, the point is I can't now use let. I have to do this, right? I need to get used to using. Okay, it's still mad about this, but I can't read the mini buffer well enough to know what's wrong. So I still need this stupid thing. Okay, good. So now it's just that there's a hole left. Okay. So that was the problem. I forgot that I made this function want the parameters, even though it's ignoring them. All right. So now I need to write this complete function. Probably equals do something, I assume. And we need to filter the arrays assocs. So I have a cave already. I can say let well, I need to look for the. I need to find the energized. Energized, let's say, equal do. Am I in the right? Shit. The problem is now that I have this parameters type, and I kind of want to, like, well, I don't think I'm going to need any parameters right now, so I should be able to just have a list comprehension, produce a list, and that should be okay. And I'll use do instead of list comprehensions because I'm more comfortable with it. But let's say actually it would be better to use a list comprehension here because of the implicit pattern failure stuff. So what we can do is say energize equal I for I energized in the cave, right? So the idea is we're going to iterate over the assocs of the cave, keeping only those indices where the octopus at that index is energized. And then I can say case energized of. If it's empty, we can just say return the original cave, right? And if there are any octopi who are currently energized, then what do? First of all, let's set them all to exhausted. Does an array have an easy way to... Kind of sucks to... It almost seems like it would have been easier to do this as a mutable array, actually. Incremental array updates. Construct an array identical to the first argument, except that it has been updated by the associations in the right argument. Oh, well, that's quite nice. That's kind of what I want, isn't it? So... we have a list of indices, and we just want to set all of them to be exhausted, right? We could do that later, I guess. So let's... I kind of don't even need to know this because it's just going to be I, or it's going to be energized. So, whoops. Let's then compute a list of the changes we want to make. Let changes equal... I don't know, I probably want to write 2 here. Sure, why not? Do let changes equal first. We're going to produce a list of I exhausted for I in... Oh, I can write this... No, this is fine. Energized. But also, we want to have this be... What do you call... What do you call, like, when something... Like splash damage or collateral? We'll call it collateral, right? Collateral of... energized, say. I don't actually think we're going to need a parameter. It can just be... Collateral is, like, tricky now, right? No, hang on. We don't... Accumulates pairs... Okay. Do I want a cum? An array and an association list, and accumulates pairs into the array with the accumulating function. Okay, so we're actually gonna use a cum and not this edit function or whatever. So we're gonna be passing... Wait, is this right? Maybe I should just do this in 2 array edits, even though it's kind of more expensive. So it takes an array from I to E and gives you back another array from I to E, provided that you give it a list of modifier actions. Oh my god, but the problem is... This stupid add energy function that I wrote, that I made it take parameters, is like, I can't use add energy in the cum array because it doesn't get to access some random monad. It would be so much easier if I had just like done this without state, I feel like. If I'd passed the parameters all by hand. This traverse could have just been map, or fmap rather. I don't even really know what I'm passing all these parameters around for. I just hope they're going to be important someday. They're really giving me a headache right now. I guess what I can do is read... Can I read the input now somehow and get out a better version of add energy? Not really, because of the order, because it takes the parameters last. I mean... it's just the worst. It's horrible. I thought I was saving myself time, but I made everything so hard. Both by using this array and by prematurely generalizing over the parameters because I don't know what they're going to be. I mean, I could throw away all the parameters, and I'm tempted, don't get me wrong. But what am I supposed to do instead? Like, one thing I can do, I think, is define like a readerless version of add energy. It's going to be a function of like an octopus, basically, right? I know I'm adding just one energy. Add energy of O. Let's params be ask. So get that out of the reader. Add energy of O is run reader of add energy 1O params. I think that we now have a version of add energy that like doesn't need to look at the parameters anymore because we read them already and are passing it in via a closure, basically. So collateral is a function. We want to find the octopuses who are currently energized. We have that. It's energized, right? Let's let bounds be... These be... hey, let's say low, high be bounds of C. So now we know the range of the array. And recipients, maybe? The filter lambda, I greater than or equal to low and I less than or equal to high of, we're flat mapping over, flat mapping something over the energized list. Neighbors, basically. This is actually going to be simpler if I just don't use composition. I always like writing these backwards, actually. Neighbors of energized, right? So each neighbors is this function that takes a coordinate and returns all of its neighbors, and we'll even include the position itself because who cares? Now we're going to flat map that over all the energized ones, getting a list of octopus indices that will be getting more energy from flashes this round. And then we're going to throw away the ones that are out of bounds. And so I think we're now finally ready to define collateral as I, and then do I need add energy? Lambda, it's kind of weird that I have this accum function that has a parameter and I don't really need one. I add energy for recipients, no, for I in recipients. So I have a list of pairs now in this changes thing. And the first part of the pair is the index I want to change. The second pair is a function of one argument, the octopus, that I want to apply to that octopus, the octopus at that position. I'm really just like writing map, except not quite. I still need to accum it, I think. So let's define C prime to be accum, no, not just accum. Accum of it's going to take a function from octopus. Here's the accum function. Right, we have to pass it a single function to update the array at each index, right? Which is kind of like not what we have. We have a different function for each index. What's the difference between accum array and accum? These indices, I don't quite understand how this is different from accum. We take a single function, an array, and a list. This takes an initial value, which I don't care about, I think. So accum pairs from the list into the array with the accumulating function. Am I crazy? Like, I don't need this accumulator at all, but I don't see a way to, like, conveniently combine a bunch of updates without using accum. And I want to combine a bunch of updates, so I guess I'll do it. Um, so I can pass it a list of these A functions. Oh, wait a minute. Am I... Takes an array of IE. Yeah, so it's going to give me what's... No, how does it accumulate? What does it mean? That it's accumulating shit. What is it doing with the E's? Pairs from the list into the array. I mean, I can make a function... Like, you can view this as a function from A to E to E instead, right? And I have a function... My A is a function from E to E, so it'll be like just identity or apply or something. What's it gonna do, though? Cum array, initial value. What? This produces a histogram of the number of occurrences of each index. Okay. So it accumulates with plus. So this is not what I want, I think. Or I guess it is, because I can just... No, because the E it's going to give me is not... No. What? It's still lost. I don't understand these docs. If I had a mutable array, it would be easy to just modify it. Possibly many times at the same index. But I don't understand what this is doing. Number of occurrences of each index within a specified range? Oh, I can use in range. I forgot that function exists. Okay, we'll go back and fix that in a minute. So this weird function is taking I plus. It's kind of taking 1. Number of occurrences of each index within a specified range. So that... Wait, so cum array doesn't even take an array. That's the difference. It's a builder for arrays from lists. Whereas a cum... What the hell does this mean? Array of B... It accumulates... I have no damn idea. Okay, well, you know what we can do? We can just make an ST array. And use it here, and that'll be the only part of our program that uses ST, I think. Yeah, I mean, Jonathan in the chat says a cum adds to the array, which, like, great, but, like, what does that mean? It's not quite a fold. I can't tell where this E is coming from. It's like... The first E it gives you must come from the position you're at. and then I don't know what the second one is. Like, it looks at one index coming from the first thing in this pair. Maybe I can, no, I can't look at this one. Why not, by the way? I don't know. Right, so like, what are the E's that it passes here is the question that I'm trying to understand the answer to. It makes sense that they're coming out of the index, the array at the index you pass in, right? I give you an index like 5 and the A is like hello. You're going to call this with 5 hello, and I'm going to give you back a thing, and I guess you're going to put that into the array. But how is this in a queue? Like, what? Is it just going to call? Like, I guess I should just try this in the REPL or something. Like, what does it do with the E that you return? Does it just write it to the array? Or does it somehow combine it with the next E that it reads? Because if it just writes it to the array, that's what I'm looking for. All right, so suppose that we said, you know, this whole thing, we're not done writing it yet, right? Complete is like something, right? And it's like, okay, there's a whole, but fine. Jonathan says for every I in the array and list, it combines their E and A. Like, that would be great. I just can't tell from the docs that that's what it's doing. And the fact that there's like, it has extra E's floating around that it could use is really weird to me. And I want to make sure it's not doing that. Okay, fine. I'll call it undefined so you'll let my program compile. So, if I said, you know, I want to accum with plus of list array, this type takes up an array from 0 to 5 of, I think the docs are just unclear. My problem is that it's possible for it to do other things than what you're describing. And I can't tell whether it's doing them because it doesn't clarify. It just says it accumes. What does that mean? And we're gonna take 0 to 5. So we have this list array, and now we have to give it like a list of updates. Let's say I want to update 3 and add 5 to it, and I want to update 2 and add 0 to it. What do I get? If I said I wanted to do 2 and add like 9 to it, okay. So it really does seem to do the thing that would be useful. It's not reusing this across other indices or something, right? Okay, all right. So accum seems to be what I want. It does what Jonathan in the chat said it seems to do. I still don't like the doc. So we have basically a list of update functions to run, right? And so accum of lambda O to OF. Like, the thing is, this is just FO, right? Like, so I think I could say flip $, for example, or flip id. But I kind of like giving these some names so that I can keep track of what they are. On the existing array, which is C. And then my list of changes thing. And then I can just say pure C prime? How much of this compiles? I'm going to type int with octopus. Where? On this line, of course. Add energy 1, 0. Alright, what GHCI, will you tell me in a little bit more detail what's going wrong here? I haven't written neighbors, that's fine. Octopus. There's somewhere here, collateral. It thought would have int octopus as a function. Why int? Where did these ints come from? I shouldn't have any ints, I feel. Oh, this should be add energy prime. Now it's just mad that I haven't defined neighbors. Great, that's fine. We've written neighbors about 100 times over the course of the many Advent of Code years. Neighbors is a function from pair of int to list of pair of int. Maybe I should give these a type alias at some point, but okay, so neighbors of xy, I'm sure I could write this more efficiently, but is do of dx from 0, 1, -1, dy from 0, 1, -1 again, pure of x plus dx, y plus dy. Like, this is not the most shockingly amazing function, but it's fine. So now everything type checks, right? I'm actually like, I'm not done because I haven't written like part 1, but I have a complete and a step function, which like in principle might work. It would be really nice to test them though. So let's put at least show on this. And see if we can do something about this at the REPL to see if it works before we start building more stuff on top of it. So maybe the first thing to do would be call complete and just pass it a pre-built cave, basically. What am I doing? Run reader complete of list array from 0, 0 to 0, like 0, 1. We'll make it very, very simple. So it's a cave with 2 octopi, and I say at 0, 0, there is an energized octopus. And at 0, 1, there is a latent octopus with 9 energy. And I'll pass parameters empty here. My parentheses not match? Something seemed wrong there. That seems right. Oh, I haven't loaded anything yet. Not this is saying drop the 0, 0, but that has no context. I have no idea where or when you're suggesting that I might wish to do that. So I can't evaluate whether it's correct. Okay. I got the run reader wrong somewhere. Run reader takes the reader function first. No, I don't need to drop 0, 0 because my octopi, when they're exhausted, it's okay to give them more energy. I left that in on purpose because it's not necessary to remove it. You're suggesting that here it's bad for neighbors to return the octopus itself, but I don't care. Because the only thing I'm going to do with this is try to add energy to it, and if it's already energized or exhausted, that won't do anything. So we're going to leave it in. Yeah, if I were doing anything else with the neighbors, that would matter, but I'm not. So run reader takes the reader of RA, which is complete of whatever. So what the hell does this type error mean? Couldn't match type. Oh, right. I don't have to specify. Here, I will remove the 0, 0. Because I called list array, not array. So it fills in the indices for me, assuming I want to fill in every possible index. Ah, right. Good. So it type checked but wasn't complete. So we successfully, this leftmost octopus who was energized became exhausted, and he made his neighbor become energized, which is great. But the contract of the complete function is that it should never return any energized octopi. So if it has any energized octopus, what it should actually do is just call itself complete C prime. It's going to loop until there are no octopi left who could explode. So if we reload and run this again, they've both become exhausted. Great. And if we said to, instead of complete, call step on that, I think takes the same arguments, right? Yeah. Then it'll tell us the same thing, but also that 2 octopi flashed. Great. And if we were to like edit this so that you know, it was latent 8 or whatever, it would say, oh, yeah, they don't explode, they flash, but why did this seems bad. Step really should never return something that's energized. And also, they shouldn't have become oh, step adds even more energy to the octopi, so that's okay. So I shouldn't. This is an incorrect way to call the function. Step expects only to receive. So I said latent 8, for example. None of them should blow up, and I should get 2 9s. Yes. And if I then make. Now it was. Okay. If I then say this one has 9, then they should both go off, right? Yes, but they became energized, which I don't think is allowed. Jonathan has said you see a problem, but has not clarified what the problem might be. Obviously, we're getting the wrong answer. That's a problem. But nothing should ever be complete if any of them are energized. Oh, wait a minute. This is latent 0. There you go. I said if you became exhausted, become energized. That's madness. You should just, to revitalize, you go from being exhausted to being like ready to go off again. So now, if I reload, we indeed get that they both went off and are at energy 0. And if I do like this, neither of them went off. If I make you like a 5 and you a 9, then one of them went off and the other one went up by 2. So this looks, the step function looks okay for small caves with only 2 octopi. And the only complication that you might have, I guess we should check like that it works with 2 neighbors, I guess. So let's say you're 9, you're 7. Oh, let's make you 8. That'll be exciting. And you also 8. The 9 should, the 8th should become 9s. The 9 should explode, making the middle one explode, which makes the right one explode. So they should all be 0s and should go by 3. Latiny? We don't want latiny. Yes, they're all latent 0, and all 3 of them went off. Good. And if this were 7, that wouldn't happen. And if these were both 9 and the middle one were 7, it would go off, right? Yes. Okay. So assuming that our neighbor's calculation is correct, which I think it is, our step function should be fine as well. It would kind of be nice if instead of returning a tuple, we had like a state function, but I don't want to add any more monads to this today. Thank you very much. We're just going to do it by hand. And now I think we're ready to write, well, we could write part 1, but since we haven't written the parse function yet, it won't be that great. Our input is not going to be a list of string, but an array. No, it'll be a cave, right? Cave. Cave. Cave has no interesting parameters. Yeah, okay. So prepare. There's a function called like digit to int or something, isn't there? Yeah. Import data char digit to int. I guess I need to read the lines in anyway, right? Pair of s is let rows equal lines s. Bounds equal 0, 0 up to length rows and length head rows. Octopi be so I want to write digit to int over concat rows. That'll give me a list of. I have a list of char. No. Yeah, I have a list of string, which is a list of char. If I concat it, I'll get a single list of char, which is just all the octopi. And then I'll convert all the digits to ints, and that gives me all the octopus values just as one straight line, and then I'll let the array function be in array bounds octopi, right? Match type int with no list array. Thank you, list array. Match type int with octopus. Oh yes. Latent compose with digit to end. There you go. So if we were to say, let's check this real quick. Prepare of 1, 2, new line, 5, 7. Let's make it 3 by 3 to make sure things are okay. Undefined array element. Oh, I have to add 1 to some things. Yeah, because hello? Why am I not? Oh, I'm in the wrong window. I clicked away to mute myself so I could sneeze. All right. So the problem is we say 0, 0 length rows, but actually it's +1 because these bounds are inclusive. Still undefined. 1, 2, 3, 5, 7, 9. We got an array from 0 to... No, this actually should not be larger, right? It should go from 0... Okay, what did I got... At 0, 0, there's 1. At 0, 1, there's 2. At 0, 2, there's 3. That's fine. Oh, it should be -1? God, numbers are so complicated. Yes, because we don't want it to be... We don't want, like, 3 to be a valid x coordinate in this example. Okay, there you go. We got 1, 2, 3 on the top row and 5, 7, 9 on the next row. Great. Okay. So, now I think we just have to write part 1, which is not too bad. Run cave 100. Where run cave 0 and C. 0n(c) equals 0n. So if we don't have to run the cave any more steps, we'll return the number of times that there have been flashes before. Run cave of, let's call this flashes, of steps, flashes, don't need that C actually. C equals do, probably. We let C prime F's come from step C, and then we call run cave steps -1 F's plus flashes C prime. Right? Is that it? It type checks. How bad could that be, right? Stack run. Does anything good happen as a result of this? Error in array index. Fuck you too. What I get for using unsafe functions, I guess. But I thought I was careful to trim the bounds to be within bounds. Oh, actually, I I forgot. I was going to filter. How do you do that inbounds thing? Inbounds in range. I guess I do still need to get the bounds of B's. Bound C. Filter in range B's. I assume this is not going to make any change. It will still not work. Oh, it does work. So my function was wrong somehow. Okay. 1713 twice. That's a little bit spooky. Did I print part 1 twice accidentally? Defaulting this to integer, which is fine. Okay. I did. Okay, so part 2, please. And you're right, we can throw away control arrow. Anything else you'd like to point out? Parameters, yes, could be a new type, but no thanks. Redundant brackets, yeah, you're right, that could go away. Redundant brackets, I always get nervous. I'm leaving those in. Okay, so let's see then if 1713, I'm gonna run it again just in case those change. Oh fuck, I blew up my input. God damn it. Okay. Let's just get that input back, shall we? So that's what I get. Okay. Stack run. Okay, I still get 1713. So let's see if Topaz thinks this is the right answer. That's a different main that I wrote for today because I wanted to have this reader. That's the right answer. Okay, cool. Well, we'll talk about that for a minute. I was thinking, when I looked at the puzzle, what are they going to do for part 2? And I couldn't see any obvious things they would change, except for like changing, like if they just change the number of steps, that doesn't seem hard. And so I thought that they might change something about how steps are calculated. And so I wanted to have a way to, I didn't want, like, suppose they changed, you know, how octopi explode or something, right? How they flash. I want this same function to work for part 1 and part 2, but part 2, I predicted, might have some different rule for octopi flashing or something. And so I wanted to thread through a parameter object through the whole program so that when I find out what's going on in part 2, I can parameterize it and I'll have the parameters available in all of my little helper functions. And it turns out that was kind of hard to do with the existing main that I usually use. So I wrote one that passes the parameters to each part. So hopefully all this pain that I caused myself will be justified by whatever part 2 is, but probably it won't. Oh, hang on, don't look. We need to just commit this. Not that it's that exciting, but day 11, part 1. There you go. I guess I should look at like whether there's anything it didn't want to commit here, but I think there is nothing of that kind. So here we go. It seems like the individual flashes aren't bright enough to navigate, but you have a better option. They seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is step 195. Oh, yeah, you're right. I'm not going to be rewarded at all for this effort. Okay, yuck. In the example above, yeah, the first time they flash is step 195. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the caverns. What is the first step during which they all flash? Ugh. Alright, well, fine. All that work for nothing. But I got some practice using Reader, and I hated every second of it. So int it's just run cave of... We're gonna have to compute the size of the array. Is that... Can data array tell me that? I assume it can. There's like a size function or something. Bounds, indices... There's not, but maybe index has it. So if I have an index, range, in range, range size. Okay. So I can ask the array for its bounds, then call range size on it. All right. Fine. So I can say part 2 of cave. Let do. All right. Let size. This is silly. Equals run cave of range size of bounds of cave. I'm gonna have to import that, I think, right? Actually, maybe array probably exports it, doesn't it? Array, yeah, it exports the index module. Okay, so that's fine. Where run cave of n cave equals do? Well, we'll call this C. We've been calling these C. C prime, C prime F comes from step C. If C equals, no, if F equals N, then pure 0, else add 1 to the result of run cave of, oh, I should just call this function go. That would be a more normal thing to do. Let n equal this. So that doesn't need to change. In go cave. And now I don't need this n anymore. Run cave C prime. So this isn't run cave anymore. It's now go. Variable not in scope n. Oh. Can't be an aware. Okay. Put that in aware as well, and then I can just say cave equals go cave, where n is this thing. Okay. So I feel like this is probably inefficient somehow, by the way. I never quite know whether, like, I've written this recursive function and I'm now like adding a thunk to it, which is like, oh, add 1 when you're done. And so this isn't tail recursive. But if it's tail recursive, I always worry that you build up a thunk in the pluses because you're never looking at the sums. We'll think about that in a minute, especially if this like blows up when I run it. $501, huh? Okay. Let me actually just double check that I understand the question they're asking. What number do you want? What does 0 count at? They flash simultaneously. So after step 193, so is step 0 the initial state? Yes. Or any steps. So if you run it once and you get this, okay, so I think I do have an off by 1 error somewhere, actually. Not because 501 is a suspicious number. I just like wanted to think more about the problem here. I guess we'll say 1. They all flashed after a single step, basically. Okay. So I guess it'll be 502. All right. Let's see what you think about that. The right answer. Okay. Well, God, that was horrible. I made a mess of this one for sure. Ugh. All right, maybe we can have some fun by ripping out all the parameter stuff. Git commit -m day 11 part 2. How long did that take? Way too long. Okay. So suppose that we wanted to throw out all this reader shit. How hard would that be? Throw that out, throw that out. Everywhere we see reader parameters, we can just replace with nothing, basically. Hang on. Followed by a space, replace it with nothing. Great. There's still lots of other problems. This add energy prime we don't need anymore. We can just say add energy of 1, basically. Don't need the params at all. This doesn't need to be pure. This is not a do anymore. Let's say instead of, we'll just get rid of this whole variable, right? Case this of, and we'll put energized here. We don't have a do anymore. We just have a let and an in. I wrote a traverse somewhere. Where was that? It's in a different function. Okay. Here we can just throw away the pure. Here, I think we're just saying let, basically, on everything. Let C prime equal fmap of that. Completed equal that. That doesn't need a let anymore. And this doesn't need a pure anymore. We can just say in. Fmap revitalize over completed. What is completed? It's an array, so that fmap still makes sense. Flashes. Equal this. Where? Equal. Seems okay. No more do's, but we should be able to say something I thought of doing before. Case step C of, if this is true, pure 1, otherwise that. Now I can just use my ordinary part 1, sadly, or my ordinary main. Read file input.text. Part 1, part 2, prepare. Is that what I usually write? Is it longer than that? I need arrow again. Import control arrow. How did that go? badly. Okay, where is it that you're upset here? Case of part 2, there we go. Met int with actual type. Hang on. Print? No. Show? What am I doing? Let me just go look at different day 10s. There you go. That actually is right, I think. Print. Yeah. So the issue is... Oh, I didn't write the... There we go. Show me the actual compilation errors, please. Here. Can't tell what's wrong, because I can't fit it in this damn window. Int with actual type FO something. Oh, I have a pure left somewhere. Oh, and this can just be that now. It compiles again. Does it work still? It does. Okay. Well, it wasn't too bad to rip out. And what is it you're still mad about? A redundant bracket. Oh yeah, that's certainly true. You don't like that, but I disagree. Okay, that's the only thing HLint wants to suggest. Let's move, well. Day 11, Yagni folks were right. There wasn't anyone in the chat saying Yagni, but in general, there must be someone out there. Let's move this type up a bit high. I don't know. That's fine. Git commit dot dash day 11 input type. All right, so how are we for time here? Do we want to, I mean, I don't really have anything else to do right now, and it's kind of nice to be in a groove, so let's do day 12. I'll just have to edit the YouTube video's title to point out that we're doing both parts. Oh yeah, I don't know if I want to do day 12. I've written so many like pathfinding things for Advent of Code in the So, all right. We there's this graph here that is helpfully drawn somewhere. Yeah. So you go from start to end, and you like. It wants to know how many routes there are. Right? No. Visiting each lowercase titled cave only once. So I assume start is lowercase on purpose, right? So start is a small cave, so you can't go like start A, start A, start A, or whatever. So I think it's a given that there can never be, in any cave system, two adjacent big caves. Because there would be then arbitrarily many paths going back and forth between those two caves. And if there aren't ever two adjacent big caves, I think that's sufficient for the the problem to be uniquely solvable, right? Whatever cave you're in, if it's big, you move to a small cave and mark it off, so you've made meaningful progress. If it's small, and you arrive at a big cave, you'll be in a different state. Because you'll have visited different small nodes. So in some sense, we just need to, while we're traversing, mark off all the small nodes we've been to. Okay, so this is not a pathfinding problem at all. It talks about paths, but you don't actually need to do any pathfinding. We'll just have so one question, I guess, that I might ask is, could there ever be an infinite path that doesn't go on its way to end? For example, might there be over here, like, you know, capital B and capital C that go back and forth between each other like this? Would Eric ever trick us like that, where we would say, oh, I'll traverse to D, I'll traverse to this, then I can, oh, I'll go here, I'll go here, I'll go here, I'll go here, and never discover that none of them lead back to the exit? That would be kind of a tricky thing to do. And would mean that we couldn't just explore indefinitely. We would have to keep track of, like, well, I guess we could solve that problem anyway by just refusing to go from a big cave to a big cave ever. Because those can never profitably lead, those are always just loops. So I think all we need to do is keep track of all the small caves we've visited, basically. And then do like a nested list comprehension where we try visiting anything we can reach. This does not seem too bad. It could even be interesting, who knows. So what's our input looks like this. And this start is just an ordinary name for a cave, but it's like the one that we start at. And so I think what we can do, we don't even have to say, like, okay, we're gonna, like, stop searching when we get to end, for example. We can just say, how many paths are there that end at end? We'll produce all the paths, and then just look at the ones that start at start and end at end. Or, well, okay, we'll produce only the ones that start at start, I guess, but... Okay, yeah, we can do this today, why not? So here's my input. It's not even that long. So let's day 12. So probably don't need any of that. Let's define a data type cave. Is a cave of a size and a label. I mean, we can just call the label a string, right? Oh, hang on, you can't see, you can't see. All right, here we go. I didn't do anything interesting. Cave size string. This is what you missed. Here, I'll type it out again, so you don't miss a single second of this action-packed adventure. Is a cave of size and string. There you go. We need a size, big or small. Do they call them large or big? Just out of curiosity. We might as well use the types big and small. Okay. Let's derive like eq and show for this. It'll probably be useful. Probably want show for this one. And we probably want a data path. There's a path from in some sense, we're going to want to maintain like a list of visited caves. But really, all the information about a cave is just part of the string, right? So we don't really want to store the size, because that would allow us to produce a cave that's illegal, right? It's a function of you could have a cave with a label that starts with a capital letter but that is marked as small, and that should be impossible. So what we should do really is just have a cave be a cave of string, and we'll define a... God, I really don't like... Let's... I guess I'll just call them strings. It's fine. It just worries me. Whoops. I don't think I need eq or anything for this. And ideally, I would put this type in another module somewhere, but I don't want to bother doing that. And make it impossible to... Well, no, it's fine. Yeah, because... Okay, what? We need a function size that takes a cave and produces a size. Easy, right? Size of... Hang on. String is not actually correct as a type, because an empty string would be illegal here. It would be an invalid cave. We wouldn't know what size that cave is. So we should do something about this. Really, a cave should be a cave of non-empty char. So it has at least one. And now there's a good reason to new type label is a label of non-empty char, and here we can say this is just a label, and these are labels, and this probably needs to derive something. Deriving. We need eq, we need ord, probably want show. Those are the main things, I guess. Jonathan is asking, is 0 caps or no caps? There's not any things named 0, are there? No, they're all letters. So really, this is a good question that I'm now arriving at. Why do we have a cave type at all if all it is a wrapper around a label? We don't need to track which like caves we've been at separately from which labels we've been at, right? I don't think we need this at all. And we could call these caves, in fact. Import data list non-empty. Is that legal? Can I do that? Looks like I can. Okay. We have a non-empty char. Great. And we need a function size that takes a cave and gives you back a size. Size of cave of h anything where is upper h equals big, otherwise equals small. Smale. And we need data char is upper. Okay. So I guess we have a few things to check at the REPL so far. If I said, what is the size of a cave of S, let's say, tart, the S tart. I have to wrap this in parens here because it's an operator and not type that dang backslash. That's a small cave. That vtart is big. Okay, so that seems fine. So we kind of want a function that takes, our input will be a list of path, presumably we'll do that later. Well, actually, let's do it now. And prepare is undefined. We'll write it later. What we want is a function all paths takes a list of path, or let's say all routes, and produces a list of, I mean, I guess for part one anyway, we don't care about the path itself, just how long it is. But I think producing the paths would be, it would be a mitzvah, right? It would be it would be a good deed that might turn out to be useful for part two. So it's a list of cave, I guess. That is all the ways you could traverse from start to end, I guess. So all routes is go of s empty, because we're going to need import data set qualified as s, where go, oh, you know what, we should also say start and end are both non-empty, no, they're caves. Start is s tart, and end is end. So in case you're not familiar with non-empty, it's a string that guarantees not to be empty. And the point is that there is no like string to non-empty function. There is, but it returns a maybe. Here I don't want a maybe, I want an actual guaranteed non-empty. And so the constructor for non-empty is just like a guaranteed thing on the left, and then a list of that thing, which could be length 0 on the right. So this is how we define start and end as non-empty string. Okay, so, and we'll go at start here. So that's our starting state. Go visited current equals do. Let's path from 2 comes from, oh, hang on, visited cur paths. He comes from paths here. Thanks, YouTube, for turning that useful Haskell data type into data constructor into a weird emoji. Yeah, so that's just the constructor for non-empty. Oh, whoops, I typed data set wrong up here. Okay. Did that compile before? I feel like I tried compiling while that was there and it said okay. That's a little, must have been wrong. So first, let's I like this could just be a list comprehension. I don't like list comprehension. Give me import control monad guard. One day they'll put this in base, I hope. Prelude. They moved a bunch of the like useful applicative operators into Prelude, but not like there's still stuff in control monad which I feel like is essential day to day, like guard. Even though it's day 12 and it's the first time I'm using it, I feel like it's essential day to day. So let's guard that from is cur. We don't care about any. Hang on. No, that's not true. Because the paths are bidirectional. Right? That is true? You can go... Let me look at the input here. You can go from start to A. Maybe it isn't bidirectional. There's an A to B here, and there is no B to A. But start B, A is allowed. So yes, these are bidirectional paths. Okay. So I guess what would be nice to have then is a function called, let's say, orient. It takes a cave and a path and returns... Really? I mean, I guess I should be honest, right? It should return in maybe a path. No. Don't be dumb. It should return maybe a cave. I was going to say, oh, well, reorient it so that it's the from is where you currently are. Oh, like I can just return only the second half. Yeah, okay. Orient cave C and path A, B if C is A equal just B. If C equal B equal just A, and otherwise equal nothing. So oriented may be a bad name for this now. We'll call it destination. Other end? I don't know. Dest is fine for now. So we don't need this guard at all. What we can do is say path P. Oh, actually, don't do structure. Just P in paths. Two come from maybe to list of dest of P, dest of cur and P, and we're gonna need import data maybe to list, please. Okay. So in this way, we're getting the destination only if it comes from where we're going. Now I want to... Yeah, I think we're going to need guard. We're still going to need it, but yes, very funny. I agree. So... The reason we're going to want guard is we're going to want to make it illegal to visit a small cave we've been to. And we're going to make it illegal to visit a big cave if we're currently in a big cave, right? So how exactly do we do that? We look in visited, right? But let's just say let valid equal case size cur of? I guess I really should, like, I could lift this function, this, like, size cur, I could lift it higher and not compute the size over and over, I guess? But, like, passing that through over and over is also going to cost something. We don't really care that much about the costs anyway. Case size cur of big. If we're in a big cave, hang on. Let's actually do this case size 2 of. So if 2 is big, then it's valid to visit it only if, exactly if, the size of cur is small. Right? We can go from a small cave to a big cave, but we should never go from a big cave to another big cave. And if size of where we're going is small, that should be allowed only if not s.member to visited. Finally, let's guard valid. Take that. Right. We've chosen our from and our to. I guess what I've done is not really quite correct, because I said I wanted to return all the paths we've taken, but I haven't. We visited start. I think what I need to do is write start cons f mapped over this go thing. Basically, every path returned by go, we're going to add to the front of it, I'm visiting the start. And let's let I can just like recursively call something here, right? I can say to mapped over go of s dot insert to visited and then also to paths. Oh, hang on. I can actually put the paths here and then not have them there, right? Does this compile at all? No, of course not. Ah, good point. Wait, is it a good point? Start and end are both caves. It's complaining that sometimes I'm putting... Oh, I'm not... Okay, I haven't wrapped those in the right constructors yet. I just haven't compiled this in a while. Okay. Okay, now a few more problems. Couldn't match, so I'm calling equals on... Ah. No, hang on. Paths don't have labels at each end, they have caves. So I can just take C here and not cave of C. This compiles. Great success. So, I think we're kind of done computing all the routes. We just have to like parse the input into a set of caves and paths, or actually just paths, right? Although, oh, you know what's funny? We can, it's kind of wrong to return a list of cave. We can do a bit better and say it's going to be a list of non-empty caves. There you go. Although, something's not right, is it? How do you add to a non-empty? Data list non-empty. Okay. Oh, it must be use mappend, right? These should be monoids. Length. Oh, and of course, how nice. Head and tail and init. And last is a total function. I can just call last and not be sad. Okay. I think it'll be overriding the one in Prelude, so if I say what is the type of last, it'll say it takes non-empty. Okay. Ah, here we go. This is the function I want. Prepend an element to the stream. Okay. Great. So this, instead of using the constructor here, I should use that. Okay, this remarkably still compiles. So we've returned now a list of non-empty characters, right? Non-empty paths, because we know it starts at start, and we're also, by the way, going to know that it has end at the end eventually. So I guess we could just leave this as is, and it's the list of all routes that exist. Something's not right. Something isn't right here. And what's wrong is that I don't really have a base case for when, like, you run out of paths. Or when you get somewhere, if there is no path, we're going to say, oh, there were no routes in this cave. But where you are is a perfectly valid route, right? So... Oh no. This is so sad because now my go function can't return non-empty lists because there might be no path, right? But I think it can, because we can say here that wherever you are, there is a single path which is to go nowhere, right? That's allowed. And so what exactly should I be doing in that case? It's pure of empty list, right? And then you can also, if you like, continue. All right, so something's wrong here, and yeah, it's upset about this. That's fine. The point is, this go function is going to return maybe empty paths. So it'll be actually returning lists. And then at the front of each of those, we'll cap off, oh yeah, you could go to start. Great. I hate that it's still got this stuff red, but it's apparently, you know, correct. Redundant bracket? Yeah, that's true. Wait, no, not that one. What the hell are you even talking about? There's no parse error there. That's fine. All right, let's test this function a bit. What if we said we're all routes from I've already forgotten the signature for all routes. It just takes a list of paths. So path from cave of start to cave of these things must be applicative, right? Can I just say pure? Yeah. Pure of B. So there's a path from start to B. There's also a path from... No, start is already a cave. Path from start to cave of pure end. Oh, hang on, let's just say end here. And also a path from cave of pure of B to end. So this is a very simple cave. It has or cave system. It has 3 caves. You can go from start to B, you can go from start to end, and you can go from B to end. So there should be a total of several paths, right? It looks like 2, but we're not filtering yet for paths that go from start to end. So you could stop at start. You could go from start to B. You could go from start to B to end. Or you go from start to end. I think that was 4? Oh my god. It's so long. Ambiguous occurrence, okay. I was wondering when this would start happening. Import prelude hiding start and B is valid too. You are correct. That would, so there are more like 5 paths. Import prelude hiding head, tail, and import data list not empty, hiding length for now, I guess. Reload 20. Well, that is too fucking many. Okay, good. We're learning. We've made a mistake. So let's handle just one route from start to end. Ah, I didn't mark start as visited before I started going. So it was legal accidentally to go from start to B to start to whatever. Okay. So not s.empty, but in fact s.singleton of start. And now it says you could go from start to end, or what? Oh, you could go from start to nowhere and then just stop, or you could go from start to end and then stop. Okay, that's better. And how many routes are, well, let's call length first. It's 6. That's close to what I expected. So you could go from start to nowhere. You could go from start to B and then stop. You go from start. Could I use pure start? Oh, you mean when defining the you mean here, right? No, because sets aren't applicative. So pure isn't valid. They're not applicative because they can't hold any values of any type. They can only hold values of ordered types. So pure is not defined for a set. We go from start to, we can stop at start. We can go from start to B and then stop. We go from start to B to end and stop. Oh, of course, you can go back to B again. You know, from start to B to end to B. Yes, okay, so 6 is correct. We just were not very creative when we were counting them earlier. And if I then filter for those paths that end at end, filter of equal end dot last over this, we should just get 2, right? Last and oh, data list non-empty has filter? That's gross. It's not gross. It's probably a good. But oh, filter is sneaky, isn't it? Because it might return an empty list. Interesting. But oh, head and tail. Okay, I'm not using tail yet, but let's hide last as well. Maybe I meant... So all routes is returning an actual... Oh, it's returning a list of non-empties. I could have it return a non-empty of non-empties. Because there's always at least one route, right? But that would be much harder. I'm not going to do that. So we actually do want preludes filter here. Yeah, so now it says you could go from start to B to end, or you could go from start to end. So that's correct. So this seems good. And if we try to trick ourselves here with another path here, path from cave, oh my god, I really should have had defined some variables for this. Cave B to cave pure A. So there's a loop here now, going from B to A to B to A to B to A forever. We should be ignoring that because we're saying I'll never go from a big cave to a big cave, and indeed that seems to work great. I think if we just write the parser, we'll be like pretty much set now. So give me import text regex applicative, please. And I shouldn't need common because I'm not parsing any digits or whatever. Give me a type regex a is rechar a. If I were a good Haskell programmer, I'd be using text for all this stuff instead of strings, but whatever. Although non-empties is kind of nice. You haven't? Is there a non-empty text kind of thing? I don't know. So we need a, like, basically we need a parser for for path, right? So path is a regex for path. Path is path of many. Oh, sum. Sum is what it's called, not many one, right? These days they call it sum. Sum label char, and then ignore a hyphen, and then some. No. Cave, where cave is cave of So sum is tricky, right? Because sum is going to be a parser for lists. They'll never be empty, but it's not going to be a non-empty of list, which is a little annoying. Can I just define my own thing? I guess I can. Cave of label? Okay. We'll just keep kicking the can down the road, and eventually I'll have to write some meaningful code. Label is lift A2 of cons. Is that right? Yeah, that seems right. Of label char and many label char, right? Yeah, many one exists. I don't know what sum1 would be the point of sum1, but it doesn't give you back a non-empty, I don't think. I think I mentioned many one, and it exists, but it's just an alias for sum these days. I mean, I guess we can look in text regex multiplicative, why not? Text regex multiplicative. So sum, empty, and many, yeah, returns the lists, right? So the problem is that while this is a great function, it returns an f of a list that's one or more. It doesn't return an f of a non-empty list. That's not quite what we need. Label char is psim of not equal a hyphen. And so prepare is basically just from maybe empty list traverse equal tilde path lines. Oh. I need from maybe as well. From maybe. It compiles. That's nice. So if I were to say prepare of start A FF B. Oh, hang on. There shouldn't be a. There you go. And then B end error. Error? I didn't think I had used anything partial in here. What? Oh, did I not define prepare? I did. Oh, I didn't reload in that. Okay. There we go. So parsed, there's a path from start to A, a path from F to B, and a path from B to N. Great. So that seems good. Now, I didn't ever actually, I guess I should write, filter equal end dot last over that. Okay. So I think we can write part one now. Part one is an input to int, and you want to know how many paths there are, right? Not some weird thing that's sort of related to that. Find all the paths from start to end, right? How many paths visit small caves at most once? And they all end at end, right? That's what you're asking? Start at start, end at end, and don't. Yeah, okay. So part 1 is length dot all routes. Is that it? Okay, seems fine. Let's try it. $3,292 seems plausible. That's the right answer. Great. So let's make sure there's not anything crazy in here that I don't want to commit for whatever reason. I think this is all fine. Day 12, part 1. Okay, on to part 2. You can visit a single cave twice. Okay. Oh, you can visit a single small cave twice. But not start and end. Okay. So that's a little cute. So what do I mean, do I have to do anything weird here? I think I can just like pass a parameter to all routes basically. All routes basically just needs to take like a have you cheated yet parameter. And we'll pass true for part 1 saying yes, I've already cheated, please don't cheat anymore. And for part 2 we'll pass false. Seems fine. It's still not totally trivial to update all routes to take cheating into account. Now, it's a little annoying that you can't visit end or start twice. Okay. We could generalize this to like number of cheats left, I suppose. Right, because the paths never change. I was like, how come paths is here? Yes, that's correct. So it needs a parameter. Kind of annoying. Where exactly do you put the parameter? Do you put it here? I think you can. I really don't want to use a bool. Because it's not very descriptive. It's actually like a little bit tricky, I think, because I didn't want to have any special casing for small or end around here. Yeah, and we have to basically, if we ever reach end, we have to say, like, it's never valid to visit start. And it's never valid to exit end. And then we have cheating for other stuff. So I guess we can do a few things. We can first guard that cur is not end. You're not allowed to leave end. And then we can guard here that 2 is not start. So that's, now we can just handle cheating irrespective of the concept that start and end are special, basically, right? Go. I'm looking at this partial application here. It doesn't make any sense. I'm like, it clearly is right, but what happens? This current here. Did I really use fmap for composition accidentally? No. Go of visited. Oh, go only takes 2 parameters. I was like counting go as one of its 3 parameters or something. Okay. So this is fine. So what are the arguments to this fmap here? It's filtering the result of calling go. So if I want to pass an extra parameter in here, I can compose with go and write fmap this filter function. Oh, I'm like so bad. What is happening? So I'm calling, okay. I'm adding start to all of them. So this really ought to be composition then. Really, I can just map, in fact. So we can say go takes visited current and cheat mode. Cheat mode equals this. And we'll just ignore cheat mode for now. Oh my god. Importing all of data list non-empty was a disaster. I haven't defined cheat mode, so data cheat mode is cheating allowed or no cheating. So go a set and start. Oh, I don't have to handle start especially anymore because we're saying it's invalid to ever visit start again. I just won't look at the list if we're at start. But okay, so go SMT start is a function from cheat mode, right? So why is this? I could just like not do this 0.3, but like, why do I have to? Oh, that adding start is in. What am I doing? Why have I written map of filter or something? I don't think there's any reason to do that. So I want to filter these and map that. Very good. Go SMT start. All right, whatever. CM, there you go. Why do you care if there's no, I'm writing length on some? Oh, because I haven't fixed, okay, so that was right. I just haven't, no cheating. Line 28? What? Oh, this should be like that, I guess, right? I'm just making things worse. Flipball routes, you think? Well, in that case, I've put the arguments in the wrong order. I think what I meant is this. I shouldn't be flipping it. I should just be giving it a better type signature. That's why I put CM at the front. Okay, so this compiles. And if we run it, we get 3292, which I think is what we got before, right? Yes, it was. Okay. Cool. Cheating allowed. Okay. So we have to basically say yeah, sure. Or let's say new cheat mode case size to cheating cheat mode. Oh, this is Haskell, right? We would call it this, right? So if it's big, any CM, I guess, will return the CM. I'm gonna take a quick restroom break actually before I finish this up. Well, have fun out here all by yourselves. All right, we're back. Anyway, I am. I don't know about you guys. Maybe a good time for you guys to take a break as well. We were in the middle of writing the handling. So right, if where you're going is big, you don't really care in this case. I mean, I guess we should say so whether or not we visited, we just return the new cheat mode. If it's small and ignoring cheat mode, you have not visited this, then we can just say, yes, you can visit it, and cheat mode stays the same. Small cm true, if you have, okay. Cheating allowed, true. Then you say, fine, you're allowed to visit it, but no cheating now. And finally, small, no cheating, basically. True. I mean, I guess we can, it seems like there should be some way to clean this up. False. Cheating, right? Like these two cases really ought to be combined. Yeah, so I guess we can do that. So let's give cheat mode an eq instance. And then we can say small cm true is cm equals cheating allowed, no cheating. So if you were allowed, let's just look at these three cases and make sure they make sense. If you're visiting a big node, regardless of cheat mode, it's only legal if you're currently in a small node and you don't change the cheat mode. That makes sense to me. If you're visiting a small node and you've never seen it before, then you're allowed to visit it and you don't change the cheat mode. If you're visiting a small node and you have seen it before, then you're only allowed to visit it if cheating is allowed, and then if you do, you can't cheat anymore. So I actually feel like it would be a little bit nicer to put this cheat mode argument last. I'm not sure why. Obviously, it makes no semantic difference. It just seems like a little bit more. All rounders? Yeah, it's not allowed. You got me on that one. This compiles, and it seems like it might even be correct. Let's run it and see. It's a larger number. That's really all I could have asked for. It's a larger number, but you know, not by like 8 digits or something. I've forgotten my stream hotkeys. I almost hung up on you guys, but instead we're going to switch to. That's the right answer. Cool. So we did it. Not too bad. A fairly interesting program, I think. Nice to use non-empty, I think, as well. So that we can, you know, we have these like non-partial functions. We can guarantee that you really can for any cave. Oh, hang on. You guys can't see this again. All right. Nice to use non-empty. It's nice that cave is, or size is now non-partial, a total function. Returning a list of non-empty caves is actually a little bit nice. Because it also means that this last call is total as well. I still think it would have been nice to return a non-empty of non-empties here, but that was a lot harder, I think. Well, maybe not. Maybe I could have just, in this case, pured an empty list in here first or something, and it would have been okay, but whatever. Parser was very simple, although a bit more annoying to write than necessary because we wanted non-empties instead of lists. But again, I think that was well worth it. All right, I guess we'll just commit this. Day 12, part 2. So someone in the chat remarked that it's only half an hour until day 13. Why not just hang out on stream? I don't know. I'm gonna go eat, and hopefully, having gotten back on the wagon, I'll be around to stream part 13 later tonight. But probably not right at 9. It's gonna take me a while to eat. Maybe an hour after that or something. I don't know. You know, keep your eyes peeled for smash that bell button on the YouTube subscribe to be notified. Yeah, there you go. I don't know. Do whatever you want. Yeah, I think we're done here. Long stream. At least I did 2 puzzles today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.